Hey, what's up everyone? This is Easy Speeds and Feeds, and today I'll show you how to thread mill while using a 3 plus 2 plane system. So like a 5-axis type thread mill. So here's the part, and what we're working with is a part that's already finished, and we just need to add threaded quarter 20s in those angled faces. So the through holes are done, as you can see in the stock model, and we're pretending the customer wanted a change in the part, so we're just going to add some quarter 20 holes in there. So first thing we got to do is add a plane. We'll do it from solid face, and we'll just click on the face itself. X and Y look good, so we'll just click the check. We'll call that plane 101. So now we are oriented correctly and we have a good plane to start making toolpaths with. We're going to just start by spotting the hole. We'll just select something out of the library. We'll edit the tool. Always edit your tools. We'll go to easyspeedsandfeeds.com and just grab some speeds and feeds. That'll work. And we're just going to pretend like it's a titanium piece. So go 3/8, 50 surface footage. Rev will go 5,000. So we're looking at 500 RPM. We're actually going to cut that feed rate in half. I usually cut all the feed rates in half on my spot drills to have them have a longer life. So go 1 inch a minute. That looks good. Depth, we'll use the depth calculator after click on absolute. I always work in absolute. So depth, finished diameter, we'll just type in 260 because it's a quarter 20. And now we'll auto-populate the depth for us, so it's all calculated out. Change your work coordinate system to 100 and your tool plane and construction plane to 101 because 100 is where you touched off and the kinematics knows where 101 is. So Mastercam will tell your machine how to move. So we're just going to copy it and paste it, and we're going to add a drill. Same thing, we're just going to go in the tool library and pick something out. So 201 drill, easyspeedsandfeeds.com. Looks like we already typed it in. So about 950 RPM and 1 inch a minute. Okay, we're going to peck drill it. Keep that tool cool. We'll go light pecks because titanium definitely heats up the tip of the drill, which will cause it to break if you don't peck it. Planes are looking good. So on 101 and 100, we're going to both change the work offset to 0. Because if you don't do that and you post these toolpaths, you'll think 101 is G55, which will cause a crash. So your touch-off plane, which is 100, and your kinematics plane, which is 101, need to know that they're both on G54. So next we're going to thread mill, click the check, and go to tool, and we're just going to create a tool. So we have a couple tools here. I'll try my 200 thou thread mill, and drawing your thread mill is actually pretty important. So you want to get as accurate as possible with this. And go to easyspeedsandfeeds.com. Head on down to Carbide Threadmills. We'll go middle of the road speeds and feeds. So 150 surface footage, 5/10 chip load. And we'll type that in, click finish. Threads per inch, 50 thou, that's right. Major thread diameter, we'll change it to 1/4 inch. And I did just catch something. So we can't use this thread mill because it's actually the same size as the miner. So we're going to use our smaller thread mill, 180 thou one. We'll make our adjustments. So the tool Mastercam just looks like the tool we have. Okay, now when you adjust the speeds and feeds for the different diameter, and we'll just input what we got. Okay, so now on to multi-passes. We want to take a small little cut because it's titanium. We'll do 10 passes, 2 thou, 5/10 per pass. Finish passes, we'll do 1 at 5/10 and 1 spring pass. Now I like to work in absolute for most things. Top of the thread is not at 0, it's above. We want that thread milling action to go past 0, so it has a nice lead in. Work coordinate system is our touch off plane. Okay. So now we're going to verify this thing after we hit the save button. We're going to verify it. Make sure that it's not doing anything crazy. Looks like we got a little error there. So we're going to turn the holder off. Click on the Verify tab. The Compare button. Looks like Compare is not activated at the moment. Oh, that's because of that error. Okay. We'll try this again. Try this one more time. Okay, now we'll click the green button on Compare. And once it loads, you'll be able to see the areas that are not machined. The Compare option is really good for basically measuring and testing out what you're going to do. So green recognizes plus or minus 10, and blue is out of tolerance. So spotted it, now it's thread milling it, 10 passes at 2 thou 5/10 per pass. That looks pretty good. It's actually exactly what we wanted. And using the Compare, we can tell that we hit the minor and that the major is out of the minor hole, so we can tell that it's doing it correctly. So that's one hole done, and we have to do the next hole, and so it's just the same thing. From solid face, you click on that face, you make sure your X is the correct direction, which would be opposite of 101, and we call this 102. You can actually call your planes whatever you want, but if you can make them all relate to each other, it just makes programming stuff a lot easier. So we can actually just copy and paste these toolpaths. So select all of them, copy, and paste. And all you would have to do is select the different geometry and then change your planes and parameters, and you'd be good to go. So there's our little tutorial on how to thread mill on a 5-axis part. I hope you guys liked it, and subscribe for more. Thanks.